Hi there, Tutor Bednigo here. Welcome to today's session. So today we're going to continue with our series of videos meant to help the grade 12s prepare for their final exams. So if you're in grade 12 or you're intending to write GCE next year, please stick around because these videos will be very helpful for you. So we are currently solving Mathematics 2023 Paper 2 Internal, and we're now on question 6b, which is a question on vectors. So the question says, the diagram shows a trapezium OABC in which OA is equal to 2 vector A, OA is equal to 2 vector A, OC is equal to 3 vector C, OC is equal to 3 vector C, AB is equal to 3 times vector OC. AB is equal to 3 times vector OC. So what this means is that AB, this vector, is 3 times vector OC. So now what is vector OC? Vector OC is this one here, which is 3 vector C. So when we expand here, we're going to get 3 times 3 vector C. It's going to give us 9 vector C. So the value for AB is actually 9 vector C. So we can actually plug in that value in advance. So AB is therefore going to be equal to 9 vector C. And then we're told to say D is the midpoint of AC. So D is the midpoint of AC. Now let us look at the question. So it says express in terms of vector A and O, vector C, AC. Okay, we're asked to find AC. So when you're dealing with a question on vectors, always use a path with known values. Okay, we can move from A to C using this route. We can also pass this side, or we can go that direction. So the easiest route is the one that already has values given to you. Okay, so the easiest way we can move from A to C is by going to O and then going to C. So meaning it's going to be AO plus OC. That is the best way we can move from A to C. So let's have our solutions over here. So I'm trying to find that is question 6, B, Roman numeral 1. We're trying to find vector AC. So we said we can go to O. So it's going to be AO plus OC. AO plus OC. So another thing you need to take note of in vectors is the direction of the vector. When you're going against the direction of the vector, the value for that vector changes to a negative. So like in this case, if you're moving from A to O, you can clearly see that the direction of the vector is in this direction. So when you're moving from A to O, you are going against the direction. Therefore, this will change to negative A. Okay, this one, if you are moving from A to B, the value is going to be 9C. But when you're moving from B to A, it's going to be negative 9C. So what is AO? AO is going against the direction, therefore it's going to be negative 2 vector A plus, what is OC? OC is going in the same direction as the vector, therefore it's just going to be positive 3 vector C. And then it is also recommended that your final answer starts with a positive term. So we're going to simply rewrite this answer like this, so that it starts with a positive value, and we are done with that one. We now come to question 2, which says OD. How can you move from O to D? So we can move from O to D by going to A, and then we go to D from A. So it's going to be OA plus AD. Now we need to understand what is AD. So if D is the middle point of AC, meaning AD is half of AC. The distance from there to there is half of this distance. So AD is going to be equal to half of what? AC. So meaning we're going to say OA plus AD. That's number 2. Vector, what are we finding? OD is equal to OA, vector OA plus AD. Okay? OD is equal to, what is OA? OA is this value here, and we're heading in the same direction as the vector, so it's still going to be positive, like that, plus, what is AD? We said AD is half of AC, which is this expression here, so it's going to be 1 over that. And then OD is going to be 2A plus 1 over 2. What is AC? AC is the one we found up here. So it's 3 vector C minus 2 vector A. And then we can simplify. OD is going to be equal to 2A plus, so this times this is going to give us 3 over 2 vector C. 1 times 3C is that there, okay, over the denominator. And then positive times negative is negative. So now this one is the same as 1 over 2 times 2 vector A. So these 2's can cancel. You just remain with the vector A there. So that's what's going to happen when you expand these values there. Then OD, you're going to say 2A minus vector A plus 3 over 2 vector C. So I've grouped the like terms. This one and this one are like terms, and that's what we have there. So meaning vector OD is finally going to be 2 vector A minus A. There's an invisible one there, so we're going to say 2 minus 1 there. It's going to give us a 1. So instead of saying 1 vector A, when the coefficient of a variable according to algebra is 1, we don't write the 1. So when you have 1x squared, you just say x squared. So even when you have A, 1A, instead of saying 1A, you just say A. So that is what we're just saying A. And that's actually why we have subtracted with a 1, because we know there's an invisible coefficient there, which is a 1, which we've not indicated. So it's going to be 2 minus 1, giving us 1A. And then we don't write the 1, we simply say A. What do you remain with there? Positive 3 over 2 vector C. So this will be our final answer, and we are done. We'll go to the next one, which is vector OB. So how can you move from O to B? We can move from O to B by going to OA, AB. So it's going to be OA plus AB. Then we would have found vector OB. So OB is going to be equal to OA, OA plus AB. So OB is going to, what is OA? OA is 2A, 2 vector A, plus what is AB? AB, same direction as a vector, it's going to be 9 vector C, and this is your final answer because you cannot simplify this any further than that. These two are unlike terms. We are done with that one. So the first three were actually 1 mark each, and then this one is 2 marks. So now how can you move from B to D? Okay, so B is here, we are coming to D. So we can move from B to D by saying, remember we said you always use a path with known values. So we can't come this way because we don't know the value for this vector, nor do we know the direction for the vector. So we're going to go here and then we come there. So it's going to be BD is equal to BA plus AD. This one seems like it will need some space. So let's do it from up here. So this is B, Roman numeral, and that's actually 4. Okay, we're finding BD. So we said we can move from B to D by saying BA plus AD. So BA plus AD. So BD is going to be equal to, what is BA? So BA, we're going against the direction of the vector, so it will change to negative 9C. 9 vector C plus, what is AD? AD, we say it is half of AC, which we found somewhere here. Is it? I think we've erased it. So half of AC is the value for AD. Okay. BD is equal to negative 9 vector C plus 1 over 2. That was 3 vector C minus 2 vector A. Okay. AC. So negative 2A is what we have there. Positive 3C. Okay. That is that. And then we can simplify. We can actually expand the brackets there by multiplying this with that. So we're going to say this will give us 1 times 3 is 3 over 2 vector C. Positive times negative is negative. Then we said these tools will cancel. So we're just going to remain with vector A. I explained why they cancel. At this point, I'm sure you understand why. Okay. And then we can simplify these because they are like terms. So you can actually say over 1, and then we divide by 2. That's our common denominator. We can now say 2 divided by 1 is 2. 2 times negative 9 is negative 18. Vector C, we bring down that sign. 2 divided by 2 is 1. 1 times 3C is still vector C minus A, which is going to give us, there when we simplify, we're going to get negative 15 vector C over 2 minus vector A. So let us write this one properly. It looks like a 9. Okay, vector A. So this will be our final answer because you cannot simplify it any further than that. So that's basically how you're supposed to answer this question on vectors. What you need to take note of is you have to use a path with known values, and you also have to take note of the direction of the vector. If you're going in the same direction as the value for the vector becomes positive. If you're going against the direction, it becomes negative. So we're actually done with 2023 paper 2 internal section A. We're now going to 2022 internal section A in the next session. So that is that. If you found this video beneficial, be sure to give it a like. And if you're watching this for the first time and you'd like to see more of such content, be sure to follow or subscribe in case you're watching this from YouTube. And also invite others to benefit from these videos. Otherwise, thank you for watching, and I'll see you in the next one.